Welcome to Study Loop.
So in our problem, we have mercury, 1 kilogram of it, at minus 39.6 degrees Celsius. But it is in its solid form. Now we dropped it into a calorimeter made of 0.620 kilograms of aluminium and 0.4 kilograms of water, which are at 12.8 degrees Celsius. And after this, the final equilibrium temperature was 5.06 degrees Celsius. We want to find out the latent heat of fusion of mercury. We are also not given the specific heat of mercury, which is 138 joules per kilogram degrees Celsius. So now the amount of heat released from the amount of heat released from the water and aluminium corresponds to mc delta T, whereas the amount of heat gained by the mercury corresponds to the amount of heat that was used to melt it first. So that's mass of mercury times the latent heat of fusion plus mc delta T. Notice that these mc delta T's are different. So from this we can see that the latent heat of fusion of mercury is mc delta T for this setup. So that's mass of aluminium times the specific heat of aluminium plus mass of water times specific heat of water times delta T for the whole system minus mass of mercury, the specific heat of mercury, and delta T for mercury, which is different, and this whole thing divided by mass of mercury. Of course, we can separate the terms. So we can see that the mass of aluminium is 0.62 kilograms. We know that the specific heat of aluminium is 900 joule per kilogram degrees Celsius. Notice that the units here are kilograms. Plus the mass of water is 0.4 kilograms times the specific heat of water is 4186 joule per kilogram degree Celsius. The whole thing is multiplied by delta T, which is 12.8 minus 5.06. Now minus, we have mass of mercury, which is 1 kilogram, times the specific heat of mercury, which is 138 joule per kilogram degree Celsius, times delta T for mercury, which is 5.06, the final temperature, minus 39.6 degrees Celsius. Now this whole thing is divided by mass of mercury, which is 1 kilogram. This, when you substitute into a calculator, turns out to be 1.12 into 10 power 4 joule per kilogram. Notice that our degree Celsius cancels out and our kilograms cancel out, but there is another kilogram over here in the denominator, which gives us joule per kilogram, our units for latent heat of fusion. This is our answer. Notice that because of the least number of significant digits we are given is 3, I've written the answer down in 3 significant digits.